high-speed ray of solar particles towards our planet, flying at up to even 5 million miles per hour. So it's a super high-speed ray of solar particles, and we need these particles to enter our atmosphere so they can begin a reaction with hydrogen, oxygen, and nitrogen in the air. Okay, this sounds simple on its own, but there's the thing we call the magnetic field in between. I call it the roulette element because that is the single thing that really decides whether or not lights are gonna happen. And you know, it is completely like God's work, this magnetic field. I mean, it's everything and nothing really. If the magnetic field is good, I don't care if the KP index is telling you it's 0% chance I'm going out, okay? Because it means nothing. Magnetic field is everything. It's bread and butter in the Northern Lights science. So what is this magnetic field? It surrounds our entire planet, okay? It's a protective shield around our planet that protects life on Earth. And it is generated by Earth, our planet. Because we have a molten metal core that spins deep inside in the core of the Earth, and it spins, and it's made of metal. It's basically acting like an electric motor, just like in a freaking Tesla, right? But slightly bigger, and it creates a electromagnetic field around our planet. Okay, so just like batteries have a plus and a minus, right? A positive and a negative side, and you know, we have north and south, and we have the two poles of our planet. We have the North Pole and the South Pole. It's pretty much the same thing. It is a positive and a negative side. Now, the magnetic field has to come out of one of the poles, go around the planet, and go in the other one. Okay, and it is flowing. Is it coming out of the north, going in on the south, or vice versa, coming out of the south, going in on the north? Now, this have a huge impact on whether the lights are going to happen or not. And the strength of the magnetic field is very important as well. So if you imagine we have our planet with the magnetic field around it, our sun propels these solar particles towards our planet, and when those particles reach our planet, they basically smash into the magnetic field, and if it's too powerful, they will just pretty much repel off and bounce off and go to Tatooine or somewhere else into deep space, but they won't be able to enter the atmosphere for a reaction, okay? But if it's weak enough, then it's going to smash apart the top layer of the magnetic field, wrap itself around the entire planet, capturing solar particles in between layers of the magnetic field, okay? And that's where the direction of the magnetic field comes in. If it's coming out of the north, flowing in towards the south, obviously, it's going to repel, again, the particles trapped in the magnetic field. It will repel it and collect it down south, and we, us north, we will not see any northern lights. But if you go down to New Zealand, the guys down there in the North Antarctica, they're gonna be seeing southern lights, okay? So southern lights is the same thing as northern lights, just when the magnetic field is looking that way, coming out of the north, going down the south, then the guys down there will be seeing southern lights, okay? But if it's coming the other way, coming out of the south, going in on the north, then it's going to collect these solar particles in this vortex of invisible force in the north, drag it down into lower atmosphere, and that's where they meet our molecules in the stratosphere, so they can begin a reaction with hydrogen, oxygen, and nitrogen in the air. Right, are you guys with me?
Yes.
Still breathing? Okay, good. Yeah, I really try to make it as digestible as possible, but this is the science of Northern Lights, basically, okay? So, how do we monitor it? What factors do we take into account mostly? So let's talk about number one, cloud cover. If we have clouds between us and the lights, chances are we're not going to be able to see them. So, and the rest of it, I mean the lights itself, is pretty much out of our control. So the primary target we can do on a Northern Light Tour is, our biggest mission is to find clear skies. Clear visibility towards wherever the lights might be showing up from, okay? So avoiding clouds is a must in finding Northern Lights. But then again, cloud covers have three different sizes. So we are talking about three different layers. We have low, medium, and high level clouds. Low and medium clouds, they form at a much lower altitude, and they typically tend to be much more thicker and more denser, so you can't really see through them. But they are more affected by weather, for example. So we have these things called microclimates, and they can affect the cloud cover in a different way than the forecast can predict it. Now, microclimates are locations such as an ocean, a glacier, a fjord, a tall mountain. These can act as microclimates, and they're going to affect the cloud cover in a different way than the weather forecast can think of it. And on cloudy nights, we usually stick around microclimates and see if they open it up or not. High clouds are not that big of an issue. They form at a much higher altitude, and they can be so thin. They are just like a filter in the sky, and you can pretty much see through them. You can see the stars and the moon and the lights. Sometimes they are so thin you can't even see them. You know, really, you don't even know they are there. Just the satellites can detect them, and if you would scream at it very violently, it may just open up as well. So high clouds are not that big of an issue. Second main factor would be, of course, the magnetic field. As we discussed, north is a bad idea, south is good for us. So it's important to track the magnetic field and see which